Problem 42 goes back to Chapter 9. Miss Keenan actually did one that is pretty much this exact same thing. The problem states, with my numbers, pretty much, a river has a constant current of 5 kilometers per hour. At what angle to a boat dock should a motorboat capable of maintaining a constant speed of 25 kilometers per hour be heading in order to reach a point directly opposite the dock? So first we need to find the angle that the boat should be heading. And it also wants you to find how long it will take the boat to cross, given that the river is a quarter kilometers wide. So look at your Chapter 9 notes and see if this had this, but I'm going to go ahead and do this. Okay, so whenever we do this, I always draw this chart, and Miss Keenan does too, because this is how it is laid out. So here's our X and Y axis. We have the direction of the boat, which is going straight up, and that's usually called VG. We have BC. Ooh, that doesn't show up well. Let me see. See that? Okay. Which is heading this way, and that's the direction of the current, VC. And then we have right here, which is VW. This is the desired direction. It's the way the boat's going. Okay, so it's where the boat's going. So let me label that in green, and let's call it VW. Okay, so from the problem statement, we can sort of figure out what these are. So we're told that the river has a constant current of 5 kilometers an hour. So since this is the river, and it's only traveling on x-axis, it's not going to have a y component. If you remember this, AI plus BJ, your A is your x component, and your B is your y component. So since this is just traveling horizontally, it's not going to have a y component, but it will have a it will not have a y component, but it will have an x, so it will have an I component. So the equation for VC is given by this. It's 5I. Okay, so now VW and VG are a little more complicated because we don't actually know how they are. So let's just label VG as N times NJ, because J is our Y component and it's going straight up. Then VW, which I'm going to write down here, VW, let's label it as AI plus BJ, because we don't know those A and B yet, and we need to solve for those. So how do we solve for this? Well, let's first write our equation. VG equals VW plus VC. Okay, so this component, which is going straight up, equals VW plus VC. Well, how does it equal that? Well, let's say we move this component over to right here. So say we have this plane. So if we move this one over here, then VC is traveling like this. That's VC. VG would then be from this point up. That's VW. And VG would still be straight up. So if you remember, if you have a vector going this way, and then from its end you have another vector that begins and goes this way, then this plus this equals this. Okay, so knowing this, now let's substitute what they equal in. So we have VG, which is N times J, which equals AI plus BJ plus 5I. Okay, so when you do this, you should remember that they should always have, equal components. So they have J's, but since this side doesn't have an I component, we're going to substitute that in by just saying plus 0I, because the I and J component should be equal. So knowing that, let's break away from the J's and just work with I's. We can then write an equation to solve for our A, because we have 0I equals AI plus 5I. The reason I'm just working with I's is because I's and J's don't mix. You can only work with I's together, and you can only work with J's together. So let's solve this. It's basically the equivalent of 0 equals a plus 5. So then get a by itself, and you find that a equals negative 5. Good, we found a. Okay, so now where can we go from there? Well, we have this equation for VW, and we need to find B now. But we're told that a boat travels at 25 kilometers per hour. So that is pretty much our magnitude of this line, which is also VW, the magnitude of VW. So we can use the equation, the magnitude of VW equals the square root of a squared plus b squared. So knowing that, let's substitute in that 25. 25 equals the square root. Let's also substitute in the a we just found. Negative 5 squared plus b squared. So let's solve for b by canceling the square root. So 25 squared, that gets us 625. And then negative 5 squared is 25. And b squared just stays b squared. So subtract the 25 from both sides. You get 600 equals b squared. Now square root the b to get rid of the square. And we don't need to worry about plus minusing the square root. So we get b equals the square root of 600. Or if you go ahead and break that apart, you would find that it's 10 square root 6. Okay, so that's our b. So now I'm gonna just draw another line, sort of break everything off. Okay. So now that we found our a and our b, I'm gonna write our equations out. So we know VC. We started with VC equals 5I. We found our we found our a and our b, so we know what our VW is. VW equals the AI, so negative 5I plus BJ, so 10 square root 6J. I hope you can see that. And then remember how we had VG equals NJ? Well, the N refers to the B that we found. So this is going to be the component that we plug in for that one. So we have VG equals 10 square root of 6J. Now I'm going to stop and let's just think about these for a second. Okay, so VC is 5I, I is our x, so of course that's traveling only on our x component. VW has a negative x, negative 5, so it's traveling this way, but then it's got a positive y, so it's going up. Okay, that makes sense. So then VG is going straight up, the same amount as VW, so that makes sense. Okay, so now that we know that, let's go ahead and solve for our angle. So we're going to use this weird equation. Let me actually get some paper first. We're going to use this weird equation. And it's theta, which is the angle we're looking for, equals cos inverse of VW, which is the vector, times VG, divided by the magnitude of VW, times the magnitude of VG. Okay, so now we have that. Let's plug the vectors in and the magnitudes in. So we have cos inverse. VW was negative 5I plus 10 square root 6J. And VG was 10 square root 6J. Okay. And then our magnitudes. Well, the problem statement tells us the magnitude of VW. It's the 25 kilometers per hour, so it's just 25. And then what is the magnitude of VG? Well, since VG is traveling straight up, it's pretty much the number that is just on the y, which in this case is 10 square root of 6. So we have 10 square root 6. I'll move this up now. Sorry about that. Okay. So there's one more thing before we can really punch it into the calculator. So when you're multiplying vectors, like I said earlier, you can only work with one thing, like x. You can only multiply x's by x's, and you can only multiply j's by j's. So this side has an I, but this side doesn't. So we need to add an I in over here. So let's rewrite this all. Cos inverse of negative 5I plus 10 square root 6j. Okay, so we're just going to substitute a 0I in plus 10 square root 6j. And that's all divided by 25 times 10 square root 6. Okay. So now when we would go ahead and FOIL at the top, we would only multiply i's together and j's together. So negative 5i times 0i, well, when you multiply a number times a 0, it's just 0, so that goes away. And we are left with just 10 square root of 6 times 10 square root of 6. Okay, so what's that? Well, you multiply the 10s together first and get 100. Then you multiply that by 6 and you get 600. So we're left with cos inverse of 600 divided by, here we just multiplied this 25 times the 10 and we get 250 square root 6. Now go ahead and type that in your calculator, and what do you get? Well, when I did it, I got that theta equaled 11.537 degrees. Now make sure to round it however it wants, but that's the angle. Lastly, the problem asked us to find how long it would take to cross the river, assuming that the river is such value wide. So in my circumstance, the river is 1/4 kilometers wide. So let's use the equation. Distance equals rate times time. We need to cross a distance of 1/4 at a rate of, now here we are going to use the component with the VG. So equals 10 square root 6, and we're just going to solve for time in hours. So we're going to divide the 10 square root 6 over, and we get that t equals, I'm sorry that you couldn't see that, there you go. Okay, so 1/4 was how wide the river is. 10 squared root of 6 is the rate that we had on VG, and it's multiplied by time, so we're solving for t. So we divided 10 squared root of 6 over, and that means that if we apply, when dividing fractions, don't ask why, flip the second number and multiply, we then get 1/4 times 1/10 squared root of 6. We multiply across, and we get 1/40 square root of 6. So if you plug that straight into your calculator, you get out a decimal, and it will want you to round that decimal to some value. So I get out 0.010206 hours. And round that however it wants you to. And that's how you find the angle. You use this equation to find the angle, and then you use this equation to find time t.